Hello guys, and today we're going to be talking about GCF. Now what does it stand for? It stands for greatest common factor. Now what does that mean? It means that between two numbers, like let's say maybe 3 and 9, we have to find the greatest common factor within this. And the greatest common factor, like what are the common factors? And to do that, we must know a strategy called prime factorization. Now what is that? I'll tell you. So let's start off with the easiest numbers, like let's say maybe 9 and 3. Yeah. And so let's go here to the, prime factorization. And the way prime factorization works is you do a number and then you find a prime number, any prime number that is divisible by the number. Like let's say the prime number that is divisible by 3 is 3. And what is 9 divided by 3? 3. Another 3. And since we finally got 2 prime numbers, the factorization ends. Why was it so quick? Because we chose a really small number. And for 3, it's a prime number itself. So its greatest common factor is 3 itself. And the common factors are 3 and 3. So the greatest common factor between 9 and 3 is 3. There. Now let's try a little bit harder numbers because you might have not gotten a thing by this. So let's say instead of this, let's say 27 and 18. No. This. Let's try maybe 56 and 120. Okay? I know that seems way too big, but okay, just listen. This is an example. So it's about to be meant to be big a bit, maybe. Now, what is the prime factor of this? So let's take 7, because it'll make the number as smallest as possible. Because we don't want it to be large, and we can do any number. Now, 2 and 4. 2, and finally we get 2 primes, so it stops here. Remember, we have to divide the number and get the composite number onto this side, or whatever way you feel like. I mean, I'm just right-handed, so I do that. So what? And now we express the factorization in powers. So it's like all the prime numbers multiplied. So, and we start off with the least one. So 2 to the 3rd power, since there are 3 2's to multiply, times 7. Because it's from least to greatest, the powers. Like, the base. And now, that is the factorization of only 56. Now we got to deal with 120. So let's see. So let's start off with 3, let's say. Okay. Now 40. Now let's go with 5. And now we have 8. And 2. And 4. And 2. And 2. Well, I haven't got much space, but you can see. Like the factorization is 3 times 5 times 2 times 2 times 2. And as I said, we express it in powers. So the smallest base is first. So 2 to the 3rd power times the second one, with the second largest prime is the second smallest prime, which is 3, times the 3rd largest prime, which is 5. And that's pretty much all the numbers we got. Now we find the factor, all the factors that are common here, and then we combine them, like multiply them. Now the only numbers that are common here is this. There. So that's pretty much, so that is a method for GCF. Now, there's actually a trick to GCF whenever you get huge numbers like this. So let's go back to the example of 120 and 56. 120 and 56, okay? Now, the GCF of 120 and 56, like, I'm just going to show you an equation. Like, let's say, this is the GCF, okay? Wait, actually, I'm just going to use the text, like a sticky note. And it'll be 26. GCF wait. Okay, yeah. So this is the wait. Yeah, so this is the equation, guys. Now, like, look, the A must be larger, okay? And the B must be smaller for this to happen. So A must be 120 in our case, and B must be 56 for this to happen. But if it is not like that, then it must be B minus A, comma A, okay? Yeah, so let's try out this method. So let's take a smaller example again, okay? Now the thing we can do with the formula is, these equations are called formulas. What we can do with them is, what we can do with this formula is that we can keep on repeating it until we get a number that is like not possible for that. And yes, there are numbers that are not possible. Like let's say 11 and 11. You can't do same numbers. Nor can you start off with a number that is 1 and something. Because you already found the GCF though. Okay, so let's try that with 56 and 120, let's say. Yeah. Now, let's say that A here, oopsie. Okay, yeah. So let's say that this is the A, and this is the B, okay? So, let's subtract this 56 from 120, which turns out to be 56, comma, 64. Well, we can do the normal method, but still, it'll still be a lot easier. Now, 64 is still the A, so let's subtract it once more, which will turn out to be 56, comma, like, let's say, maybe, yeah, so let's try, maybe, yeah, it'll become 8. And now, well, don't get too greedy with this, okay? Because we already found the greatest common factor, which is 8. Because it's the number itself. So you don't always have to do this. You don't always have to do it if the answer is still easier without exactly doing the subtraction. Yeah, so that's pretty much it for greatest common factor. So, bye-bye, guys. See you next time.